Okay, so we get 7, right, because I have to add the exponents. When the bases are the same, you can add the exponents when you multiply. So we get 7 to the 1/2 plus 1/2, which is 7 to the first, which is 7. Okay. All sorts of exponent rules today. So now we'll do 5 to the 1/4 power times 125 to the 1/4 power. So I know historically all this stuff confuses you because there's no definite way to do the problem the first time. You have to be flexible mentally to be able to look at the problem and know what to do. Like any kid that struggles in math, a lot of times why they struggle in math, they know a lot of math, but they have no idea what to do when. Anybody have that issue? Yeah, right? So you know how to do a lot of stuff, but like you don't understand what the directions mean, or you look at the problem and you're like, I don't know. So the way I think about it, I know the bases are different here, so I can't just multiply those, right? I can't, I can't add the exponents, right? So what's another way I could write it? Right? 4th root of 5 times the 4th root of 125. Now can I multiply the numbers? So that's how you got to approach these things. You might try something, it doesn't work, you erase it, try something else. But now I can multiply these two, so I get the 4th root of 625. And anyone know the 4th root of 625? Go for it, Aaron. She's looking at her chart. Sheep.
You gave it to us.
He's not here. He's not here. He is. Okay, so that one's 5. Moving on, I think we got a part D here. We're going to do, you can do this one on your own. So 3 to the 1/2 power times 12 to the 1/2 power. And I know from grading those tests that there's definitely some confusion around the exponents, so hopefully this law of exponent sheet I hand out will help you. You can write a bunch of them, use it to study, because you're going to be tested on the end of this chapter. And remember, spring break is only like 2 weeks and a day away. Okay, so it's going to be right on top of you, and you know for sure you're going to have tests in every single class right before spring break. So just think about that, because it's coming. Every single core class for sure you'll have a test, so just be ready for it. Don't blow it off to the last minute, otherwise you dig yourself a gigantic hole. Alright, so how should I write this, AJ?
Square root 3 square root 4.
Which is square root, which is... Okay, so let's do...
This is hard to get with
Of course not. Silly boy. Example 2. Now we're going to go we're going from rational to radical. Sometimes it helps you to see the direction. Let's do x is 3/5 power. So this would be a1. And then we'll do the b1. I'm going to remind you of something first, and then we'll do x to the negative 2/3 power. Okay, so where's the 5 go? Index. So it's the fifth root of x cubed to the third power, right? So underneath the radical, right next to the x, that's where you put that thing. So you learned this first semester. We had a properties of exponents section. When you have a negative exponent, what happens to it is just moves to the denominator, and only the exponent becomes positive. So if I have a problem like x to the negative second and y to the negative third, the x to the negative second moves to the denominator, and the y to the third moves to the numerator, and both exponents only the exponent becomes positive. If I have a negative down here, right, it's still negative up there. So only the exponent changes to positive. So what do I do here? What do we do on that one? It becomes 1 over, raise your hand once you know. You got the example to look at right here. Got 2 people, 3, 3 people, come on now. 4, 5, 6, Mikey. Yep, so it's going downtown. Not cube root, oh yeah, sorry, it would be cube root.
And then x to the
What's the numerator? X squared. Cube root x squared. 1 over cube root x squared. Okay, so when you have a negative exponent, that's how it works. So now we're going to, this is combining radical expressions. Next example. So if I have the fourth root of x cubed in the numerator, over the 8th root of x squared. So whenever they ask you a question like this, and you'll see it happen all the time in math classes, even in calculus, like you can't do anything. Indexes are different. You've got different x cubed and x squared. So I can't write it as a big one. So how else can I write it? A lot of times what they want you to do is write it in a different way, and then you can see the simplification. So how can I go from radical to rational in the numerator? What does that fraction become? X to the what power? X to the 3/4 power give. Right? The index goes to the denominator of the fraction, and then the cubed part goes to the numerator of the fraction. So it becomes x to the 3/4 over, raise your hand once you know. Page? X to the 1/4, right? It's 2/8, but just reducing that fraction, it's going to be x to the 1/4 power. I can still simplify now. What can I do to simplify? If I have exponents top and bottom, right? If I have x to the 4th over x squared, what's the answer? X squared. How'd you get x squared? Subtract 4 minus 2. So in this case, just because it's fractions, doesn't matter. You can still subtract it. So you get x to the 3/4 minus 1/4, which is x to the 1/2. 2/4, which reduces to 1/2. So at this point, you got to say, do they want it to be rational or radical? This one is rational. Just depends on the direction. This one would be radical. So if it helps you to put the little 2 in there so you know where the denominator went, then put it, but you don't have to. Yep.
So, I don't have, why do you want to run a 1?
Okay. So this bottom would become x to the 2/8 power, and we just reduce 2/8 to 1/4. Okay. Good. All right. So let's. What was that, example 3?
Yeah.
So 16 to the negative 2.5 power, and we want to, all it says is write each number in simplest form. So right to this direction. So if you're one of those kids that raised their hand when you said you know a lot of math, but oftentimes you don't know what to do, you got to write yourself directions like this. You make a little flashcards out of it so you know the first step. Because if you struggle in math, knowing that first step gets you started and then you're good. But if you don't know the first step, then you're kind of screwed. So what's 2.5 as a fraction? Anyway, 5 halves. So we could have 16 to the negative 5 halves power. So because we have a negative exponent, where does it go? Denominator, so it becomes 1 over 16 to the 5 halves power. So then what do we have to do? How do we rewrite it? Where does the 2 go? Denominator goes in the index, and the 5 goes next to the x. Just going to pull up the calculator because we want that. So we've got 1 over the square root of 16 to the 5th power. Okay, so let's do that. And again, you want to show as many steps as you can always. So we'll do 16 to the 5th power. And we get that big number, 1,048,576. And then we can just take the square root of that. Okay, all you showing steps like this gives me the ability to give you partial credit on the test. So let's do that in the calculator. Hopefully you guys know this little trick on your graphing calculator by now. If you don't, then pay attention. So if you do second square root, second answer, which is right above the negative sign, then it'll take your most recent answer and take the square root of that, instead of having to retype the whole thing. Handy. So we get 1,024. So that is 1 over 1,024. So let's do this one. And this will be the last example too. Negative 32 to the 4/5 power. So only if the exponent is negative do you move it to the denominator or the numerator, depending. So we just need to rewrite this. So what does this become? Okay, where does the denominator go? Index. And the numerator goes like that. So if you do 32 to the fourth power, it's an absurdly large number. So do I need to put the negative in when I do 32 to the fourth power? Why or why not? Right, because the exponent is even, it'll become positive. If you don't realize that, put the negative in. Just make sure you use parentheses though. I'm just going to do 32 to the fourth power. Oh, weird. Same number. Did we do? The other one was in 32 to the fourth, was it? Okay, so we've got the fifth root of 1,048,576. And then we're just going to take the fifth root of that. So a reminder on your calculator of how to do the fifth root. You hit 5 first, then you hit math, then you go down to the X root button, number 5 there, hit enter, and then we can go second answer, and it'll take the fifth root of the most recent thing, and you get 16. Okay, so your homework is page 386. 11 through 45 options.